Thank you. Hello, everyone. I'm Feng from Northeastern University. In this talk, I would like to introduce our work on exploring an improvisational approach to acquire social interaction. This is joint work with Professor Stacy and Marsella. To train social skills, there has been a rapid growth in social interactive agent-based systems. The agents provide a risk-free environment for the learner to explore alternative actions and practice on social skills. However, designing such agent with sufficient amount of actions and the capability to generate appropriate response require extensive behavioral content creation. Traditionally, this content is hand-authored. For instance, for the game Prom Week, it requires more than 4,000 handcrafted social interaction rules created by the agent designer. As a result, more and more work is considering a data-driven approach, especially extracting human behavior from narrative and stories provided by the crowd. For instance, in our early work, a probabilistic model was built from the crowdsourced narrative to generate social vignettes. One fundamental challenge of data-driven approach is acquiring the interaction data with sufficient variety that reflects the characteristics of open-ended social scenarios. Therefore, the main objective for this work is to design crowdsourcing methods that can acquire human interactions with sufficient variety. Specifically, we designed a crowdsourcing application based on Stanislavski's active analysis, which was developed to help actors improv under a director's guidance. Theoretically, AA consists of 3 steps. The first one is framing, where the director gives different instructions on the character's motivation and tactics to the actor. Then improvisation, where the actor play out how they think the situation may unfold, and performance analysis, where the director gives feedback. These steps are then iterated upon by the director, who will often change the instruction to the actors. AA has 2 attributes especially relevant to social knowledge acquisition. So first, the director provides different prompts at each iteration, and these prompts encourage actors to embody the character and examine the interrelation of the characters through the lens of the director's instruction, which is critical in social interaction and creative work. Second, AA requires the collaboration between different actors while each of them play a different character in the scene. In our previous work, we transformed this AA process in a narrative writing task. The crowdsourcing system plays the role of the director, giving random prompts at different stages to different workers in the scenario. To replicate the AA collaborative roleplay, co-workers worked in pairs on a scenario. Results from previous work shows that the intervention of the motivational prompts and collaboration will facilitate creativity and produce more diverse but coherent stories. In this work, in particular, we want to evaluate the question of whether AA, especially the motivational prompts, provides a means to control the diversity so that the coverage of collected data is consistent with the goal of the application. So a between-subject experiment is designed in this work to examine the following hypotheses. So first, the intervention of AA prompts could improve the overall user engagement. And also the intervention of AA prompts could also bring diversity to the collected data. The independent variable in this study is thus the motivational prompts. Specifically, we seek to quantitatively evaluate AA-based crowdsourcing in the domain of a structured bilateral negotiation. Because first, a structured negotiation with a bounded set of well-defined action type is particularly well suited for the objective quantitative analysis of the variance in the sequential pattern of interactions that the crowd worker use. Further, it is also a ubiquitous social scenario that is often at the heart of many social interactions and is challenging for people. Last but not the least, the rich interactive data collected in this work could also be used as a basis to design autonomous social interactive agent that can negotiate like human and can be embedded in interactive application for negotiation and social skill training. With that, a multi-level, multi-issue bilateral negotiation was selected in this study. It is a back and forth interaction between two negotiators to divide up a set of items to achieve their own goal. Here is a snapshot of the UI. Now let's dive into the details of it. On the top is an instruction that describes the negotiation task. In the prompting condition, it also contains the motivational prompts randomly picked from this table. As you can see here, it contains both the prompts of what types of the player the participant should play, and also a description about their goal. Next is a payoff table that shows the value of each item. Both negotiators had the same payoff table, but they didn't know about it. The remaining part was designed to enable three major types of social exchange in a negotiation task identified in Iago, namely offer exchange, information exchange, and emotion exchange. On the bottom left is the offer panel, where the participant could make an offer to his or her opponent by dragging and dropping the item. The reward value is updated in real time. They could also choose to terminate a negotiation and get the best alternative offers. On the bottom right is a chat box that was designed to facilitate the requirement of exchanging other messages and emotions. They could ask a question, provide information about their preference, or even send emojis. We recruit 200 participants from Amazon Mechanic Turk. 26 of them were excluded for later analysis due to intermediate dropout or short interactions. To evaluate the data we collected, two consistency metrics were used to validate whether the participants follow the prompts given to them. Specifically, we have the perceived goal of the opponent that was evaluated using a radio button listed with three options: competitive, cooperative, and individualistic. Those three items mapped the original prompts we gave to the user. In addition, we also ask all of them to report their goal by using the same option choices here. The following evaluation metrics mainly focusing on assessing the engagement level of the user. So first of all, the number of interactions was evaluated by the number of turns taken in a negotiation session, which indicate how much effort and time the crowd worker were willing to put in this task. Secondly, exchanging information such as workers' preference and goal in a free-form messages and text is also an important strategy in negotiation. Therefore, the number of messages were also recorded. Last but not the least is the number of offers they made in one session. Because they need to drag and drop each item individually to make the offer, all the consecutive drag and drop actions were combined together as one individual offer action. The diversity and variation in the pattern of interaction were the key factors to be evaluated in the study as well. So here we have the number of unique action pairs that compare the diversity of action-reaction pairs from two negotiators. And also number of unique action triplets that reflects the number of unique action triplets comparing the diversity of action, reaction, and counteraction triplets from the negotiation in three turns. Now, let's take a look at the result. In terms of consistency, this table shows the majority of participants in the prompt condition follow instruction. Here we compare the assigned goal and self-reported goal. For the setting for this experiment, negotiator with a goal of competitive and individualistic has very similar money incentive, which is to get as many credits as possible to get a better chance to win a lottery. It is very hard to distinguish these two goals. Therefore, for later analysis, we merge these two groups of participants as self-interest group. The table on the right shows the result after merging. And we can see 89% of Turkers follow the instruction we give them. Now let's look at the result comparing the self-reported goal with the perceived goal. We did the same merging for the competitive group and the individualistic group. And the result here shows that 58.8% of Turker could predict the opponent's goal. The number is low here, which could be because estimating an opponent's goal and preference is a difficult task in general. For engagement metrics, significant results have been found for both number of interactions and number of offers. Marginal significant results were found for the number of messages. In terms of diversity, significant results have been found for both the number of unique pair of actions and also the number of unique action triplets. So this result indicates that providing AA motivational prompts is an effective approach for collecting rich data with both greater diversity and variation of the interaction patterns. To better understand the data we collected, an exploratory analysis on the action used by the participant with different self-reported goals was also conducted. This table shows the top 3 frequently used actions. If we look deeper into the offer by dividing them into 3 groups based on the total value of the offer they made to themselves, participants with self-interest goal have more selfish offer, while participants with cooperative goal have more altruistic offer. Another interesting finding in the collected data is, unlike workers with cooperative goal, self-interest participants tend to express more about their emotions using emoji icons provided by the interface, especially more negative emotions. Cooperative players, on the other hand, tend to care more about fairness and emphasizing with the opponent, in contrast to the self-interest players. To sum up, active analysis as an improvisational technique is an effective approach to prompt the crowd and obtain rich interaction patterns. In addition, the high compliance rate of self-reported goal also suggests that AA provides a means to control data diversity in a way that is consistent with the goal of the application. With that, thank you for listening.